Okay, the derivative of ln of 2x squared minus 8. So we know the derivative of ln of x is 1 over x. So we're going to do the derivative of anything inside of the ln function. It's going to be 1 over that function. So here, since 2x squared minus 8 is inside, we're going to put that in the bottom here, 1 over 2x squared minus 8. But because this is not a x, we have to use the chain rule. So the chain rule will be 2x squared minus 8 derivative multiplied by that. And we know the derivative is 4x, so put that on the top, 4x over 2x squared minus 8. And say hello to Mira, our new addition. All right, so we're doing the derivative of ln of 4x to the 7th power. So we're going to start on the outside and then work our way in. So because we have this power on the outside first, that means we're going to do power rule, and then we'll take care of what's inside because of the chain rule. So power rule, 7 comes down to the front, 7, and then ln of the same, 4x to the 6th power, right? We did the shell. Now we're going to work on the interior. So since we did something that wasn't x, remember we do the chain rule, so we know ln of 4x. Well, the derivative of ln of anything is 1 over that thing, right? So we have to multiply it by the derivative of this, which is 1 over now 4x. But because it wasn't just x, we got to use the chain rule again because this is 1 over 4x, right? So derivative of this times 1 over 4x times derivative of this, which is 4. Okay? So power rule first, then inside, and then inside again. So there should be 3 pieces to this. And then we just bring it all together. So 4 over 4x becomes 1 over x here. And then you keep the same here, and then you put the x on the bottom. And now your final answer is 7 ln of 4x to the 6th power over x. You'll notice that anytime you do ln of anything, x, 7x, 8x, 9x, it's always going to be 1 over x because you'll notice this always happens. It always gets kicked out. Okay, so now we're doing the derivative of ln of x to the 10th power. Okay, so there's nothing outside. We're just going to start straight up with the ln rule. The derivative of ln x is 1 over x. So we're going to go ln x to the 10th power is 1 over x to the 10th. And because it wasn't just x, we have to do chain rule again. So it'll be x times x to the 10th prime. Okay, so kicked out to the side. X to the 10th prime, we know is 10x to the 9th. Power rule right there. Okay, now we multiply that by the top. So we got 10x to the 9th over x to the 10th. Right, just combine the two. And because there's no pluses or minuses, I can cancel out the x's that are common. There's 9 of them here, 10 of them here. So all these x's go away. We're left with 1x on the bottom, 10 over x. All right, now we're doing integrals. So an integral is just a reverse derivative. So you can always dummy check yourself at the end and make sure what you come up with is the original equation for the integral you're going to take. Okay, so for this integrals, we just apply as we distribute as we would a derivative. Okay, so it's separated by a minus sign, so we're going to apply the integral to each one of these. And we can also take the constants out to the front of the integral sign because the constant's not going to be affected by the integral, just the x. Okay, so here we have integral of 3x minus 4 dx. So we'll apply it to 3 integral x dx. That's what this becomes. Minus 4 integral dx. There's like an imaginary 1 in here. Okay, and now we apply the rule, reverse power rule, for the integration. So anything integral x to the n dx essentially becomes x to the n plus 1 over n plus 1. Okay, used to be we take what's at the top, bring it to the front, and then minus 1 at the top. Now we take what's at the top, add 1, and divide it. Okay, that's the rule. Now we apply it, x squared over 2. X becomes x squared over 2. Okay, multiplied by 3 because it's in the front, minus 4. And integral of 1 is x because x is the constant, becomes a constant with a derivative. Okay, and then we have to add plus c because we never know what constants were there that turned to 0. Remember, we take a derivative of any number that doesn't have an x, becomes a 0. So we have to add this constant c at the end. C stands for some number, some value that we can determine if we have other information. So the final answer would be 3 over 2 x squared minus 4x plus c. Okay, so here we have the integral of 2x to the 5th dx. So we'll take the 2 out to the front as we did before, and we will do the integral of x to the 5th dx. Again, same rule applies here. You add 1 to the exponent divided by that addition, and you get the final solution for the integration. Okay, so here we had x to the 5th, and we're going to make it x to the 6th over 6. Okay, and then plus c, because we don't know what the constant was, canceled out. And the very end, you take the 2 divided by 6 becomes a 1/3, and you get x to the 6th plus c. Okay, so now we're doing the integral of 5e to the x. Okay, it's not like the 2 to the, it's not like 2x squared or 2x to the 5th. It's, remember, e to the x, a little different behavior. But we know the derivative of e to the x is e to the x. So the integral of e to the x would be e to the x. Makes it very easy for us. Take out the 5 from the integral, put it in the front. So 5 integral of e to the x dx, that becomes 5 e to the x plus c. Okay, so here we have integral of 6x to the 5th dx. So we take the integration and do the same thing again, put the 6 in the front, add 1 divided by that number. So we get 6x to the 6 over 6, which cancels out the 6 plus c. Now we have just x to the 6 plus c. All right, we got a little bit more going on here, but it's the same thing. But now we get to use this secondary information here to figure out what the constant c is, okay? So let's just do the integral, and then we will find out what that information is, okay? So integral of 9x squared plus 5. Same rule applies. 9 goes in the front. X squared becomes x cubed over 3. Add 1, divide by that number. And then 5 is a constant, which means it's going to be an x in there, so 5x, okay? And then we have the plus c. So now the 9 and the 3 cancel out, become 3, right? 9 over 3 is 3. X cubed plus 5x plus c. Now we know that is f of x, right? The integral becomes the final function. So now we know that f of 1 equals 3. We can take that information to say that if I plug in 1 for all these x's, the final number would equal 3. So I can solve for c. Okay? So that means 3 times 1 cubed plus 5 times 1 plus c equals 3. That's 3 plus 5 plus c equals 3. 8 plus c equals 3. Subtract the 8's on both sides, you get c equals -5. And just plug that in now for c over here. So your final function, f of x, equals the 3x cubed plus the 5x. And now c is -5. Okay, same thing here. We're going to take the integral, then plug in the constant to find the constant information, and we're done. So 4x cubed plus x plus 3. Okay, so we take the 4 out to the front, make it x to the 4th now over 4. And then x becomes x squared over 2. And then 3 becomes 3x, and then we have the constant c. Do a little bit of math, and we cancel the 4's here. X to the 4th plus x squared plus over 2 plus 3x plus c. And that'll be our f of x. Now we're going to find the constant with the information f of 2 equals 14. F of 2 equals 14 here. So we plug in the 2's for all the x's, and we say it equals to 14. So now we have 2 to the 4th plus 2 squared over 2 plus 3 times 2 plus c is all equal to 14. Do the numbers out, you get 16 plus 2 plus 6 plus c equals 14. And then c will equal -10. Then plug that in over here, take that function and plug in -10 for c, and you get x to the 4th plus x squared over 2 plus 3x minus 10, and that's the final answer. Kill it.